project, I'm implementing a scheme for video-based facial recognition, and so that means applying image-based techniques to video clips. So for the goal of this project is, given a training set of clips where you know exactly which individual, you want to match another testing clip of a test subject to a person. So this involves first using face detection to extract the face regions, and then with those face regions, you apply the actual face recognition algorithm. So here you can see the general scheme. We decompose each video clip into image sequence frames, and then apply our feature filters to extract the face regions, and then also remove certain frames, whichever ones flag for false detection or no detection or multiple people being detected, and then applying the eigenface and then actually testing and projecting your testing.
My project is a reconfigurable multi-core cache system. Because nowadays we are increasingly use multi-core system, and so does a cache. We also need a multi-core cache system. But for conventional cache, there always be competing for resources. Means one core need more data and the other need less data. So there will be some competing for resources. In order to solve this problem, I implement a reconfigurable cache system, and in this system, when the size of the cache can change. I implemented a dual-core cache system. The total cache size of the two cores are fixed, but one cache can grow larger with the other grow smaller. So the baseline of this system is each core has 2 blocks, and one core can grow with reconfiguration. One core can grow up to 3 blocks, and the other can go down to 1 block, and vice versa. But here is one important issue: is how we can maintain the data consistency and coherence. So here I introduce the cache coherence protocol. I choose a message protocol, and with this protocol, I don't need when I do reconfiguration, I no longer need to write back dirty words or dirty data, because I can just do the reconfiguration, and if another core access to some of the dirty words, it will just look from the other cache.
So the idea of the project is to use effective UDP and multicasting and unicasting to transmit video packets across the network to help us reduce the amount of traffic and reduce the redundancy that exists in the present video on demand application. So what we have here is a server that has a video and multiple clients requesting for the same video. So in this case, what we are doing is we are maintaining the state of every client that's connected to the server and servicing them using multicasting instead of servicing them using unicasting, which happens in the present implementation. So packets are usually multicast to the clients, and the client sends feedback only when requested or when it's in trouble. When a new user joins in, so that the service doesn't stall, we are using a TCP mechanism to service him so that he can catch up with the rest of the videos that are being played and maintain the entire system without stalling. So we did some testing a couple of months ago, and we have results which show this. So we have a considerable improvement in reduction of stall time for users compared to the unicast and the approximate DP that we are using. And we also have reduced traffic flow into the network compared to the unicast. We have about 3.5 times the improvement compared to the unicast when we have 15 clients connected.